Hi everyone. So we'll be discussing about this ESE mains June 2024 civil engineering solutions. Right here, first we'll be going on to which one? This airport engineering solution. So what is the question given? If you just observe, you can say this is the first slide. You can say the question given here is a greenfield airport is proposed at an elevation of 250 meter above mean sea level. Right. So that airport is proposed to be located at which location? You can say 250 meters above mean sea level it is located, right? So that x value, what is it we have to go for? This is solution if you are just doing. So that x elevation at 250 meters is that given. Since it is not at mean sea level, we have to apply elevation correction pakka. Now, the monthly average of this maximum daily temperature at the site is 45 degrees during the hottest month of the year, and during the same month. Generally, what is the hottest month? Summer. Summer, May, na? Is that no? During this same month, the average daily temperature is 35 degrees centigrade, right? What is the symbols we are giving? Monthly mean of this average daily temperature is your 35 degrees centigrade, and monthly mean of this maximum daily temperature is which one? This is 45 degrees. That is the data given, you can say. And the maximum difference in the elevation is 6 meters, right? So maximum difference in the elevation means that a reduced level of this highest point minus the reduced level of this lowest point, that is given as your 6 meters, you can say, along the proposed runway of basic length 2000 meters, right? So what is the basic length of runway? L, small l is the symbol we are giving for this basic runway length 2000 meters, you can say. Then calculate the actual length of this runway to be provided, and this is given for 15 marks, you can say, right? So we are supposed to find out this final length, you can say, if you just right. So what are the different corrections we'll be having, you can say? The first and foremost correction we'll be applying is that a correction for this elevation, right? Whenever it is not at the means level, we have to apply correction definitely, right? So what is the correction we can apply? Correction for this elevation, if you consider here, generally for 300 meters elevation above the mean sea level, so that runway length should be increased by 7%. But here the question is given for in the data, what is it given? 250 meters elevation is given. For 250 meters, how much it will be, right? If you just calculate, that is your 250 into that 7 divided by this 300, this much percentage value you will be getting, right? So what is that final value? You can get it 5.83 percentage increment we have to do it, right? Therefore, what is that corrected length for elevation? You can say, if you just observe the corrected length for elevation, if you just observe corrected length for this elevation, that L1 will be equal to, so 1.0583 times L, right? Therefore that L1 will be equal to 1.0583 times, right? What is the L basic length given? That is given as your 2000 meters. Then finally, what is the corrected length for this elevation? The first corrected length comes to be, it is your 2116. This is 67 meters, right? So this is corrected length for which condition? You can say only the elevation condition, if you just observe, right? Next, what is that we need to go for? We need to go for this temperature correction also. Nice, and temperature correction also we have to go for, if you just observe, right? How can you go for this temperature correction? You can say correction related to this temperature, right? Correction for temperature. Temperature correction means it is not the temperature getting corrected, it is a runway length corrected for this temperature, to take care of this temperature effects, right? So here if you just observe this standard atmospheric temperature at an elevation x meters is equal to, what is it you can say? That is your standard atmospheric temperature at this mean sea level minus which one? This x by 1000 into that 6.5 degrees. So what is that? This is your 15 degrees minus what is that x? You can say elevation here is your 250 meters, right? Divided by this 1000 into standard atmospheric temperature at mean sea level is 15 degree. So for every 1000 meter elevation, at what happens? That a standard atmospheric temperature is decreased by 6.5 degree. And for this 250 meter elevation, right, it should be decreased by how much? 250 into that 6.5 by this 1000, right? Like that we can say. So then the standard atmospheric temperature, it comes to be 13.380 degrees centigrade, right? This is the rounded off value. Now Here, what is that airport reference temperature at this means at this elevation we have to go for airport reference temperature is what? TA plus Tm minus the TA divided by this 3, right? What is it? TA plus, you can see if you just observe, TA will be 35 degrees plus what is it? You can say 40 minus this 35, right? These values are already given. Na? You just observe these values are given in the question, right? Monthly mean of average daily temperature is 30 degree. Monthly mean of maximum daily temperature is 45 degrees, right? Divided by this 3, right? So finally, how much it comes to be? You can say that value comes to be that airport reference temperature, right? This is 5 by 3, approximately 1 point something, isn't it? So that is 36 point, this is 67 degrees centigrade it comes to be. This is your, which one you can say, that is your airport reference temperature, right? Then what is that change in the temperature we have to consider for applying correction? That is your airport reference temperature minus this standard atmospheric temperature at this elevation of this 250 meter. So what is the airport reference temperature? Just now we calculated 36.67 degrees minus what is the standard atmospheric temperature we have got at this elevation of your airport 13.38, right? So that is your delta T change in temperature will be 23.29 degrees centigrade, right? Like that we are having. Now coming to this, right, what is that? So for temperature correction as per this ICAO, if you just observe, whenever it is for 1 degree centigrade change between this airport reference temperature and standard atmospheric temperature, that is to be increased by, runway length is to be increased by 1%. And here you have got how much? 23.29 degrees centigrade. It should be how much percentage? Same percentage, that is your 23.29 percentage increment we have to go for, na? 23.29% increment we have to go for, right? Therefore, what is that corrected length will be getting if you just observe? That corrected length L2 comes to be 1 point, which one? This is 2329 times L1, right? What is that? 1.2329 times, right? L1 just now you got, na? The L1 is a value which is obtained after correction for elevation. So that is how much you can say? 2116.67. 2116. This is 67, right? Therefore, what is that L2 you are getting finally? Elevation and temperature corrections together. Final length, how much it comes to be? 2609.64 meters, right? But before applying this gradient correction, do we need to take it as it is, or we have to go for this check? Definitely, right? We have to go for this check, definitely, right? So what is that check we have to go for? That total correction, no? Elevation plus this temperature correction together. Elevation and this temperature correction together, it should not be, what is it you can say, should not be greater than this 35% as per ICAO. If it is greater than 35%, we have to restrict it to 35% only, right? So what are these values? You can say that is your L2 minus L divided by this L into that 100. So what is it? L2 you can say 2609.64 minus what is the L you can say, that is your 2000 meters divided by this L is 2000 meters into what is it you can say, 100, right? So this how much percentage it comes to be? 30.48 percentage is the total correction applied it comes to be, and it is lesser than 35%. So as per this ICAO specifications, it is satisfied, right? So do we require any modification for this, or no need to modify? No need of any modification for this, you can say, if you just observe. Then what is that next correction we have to apply? If you just observe that the third correction, it will be which one? Gradient correction. If you just observe, right? Which gradient? It is not the normal gradient we are going for. It is a effective gradient as per ICAO is to be considered, or FAA you can say, as per this FAA. So this correction is as per which one? This Federal Aviation Administration or Federal Administration Aviation, right? FAA. The first two corrections are as per which one? ICAO only. Temperature correction, it is as per this ICAO only. So this is elevation correction also as per this ICAO only. Okay. But this is as per this FAA. First of all, if you just observe, what is the effective gradient percentage, you can say, that is your reduced level of this highest point minus this reduced level of this lowest point divided by this length of this runway just before considering this gradient correction, whatever the length available, right, into 100. What is that value? You can say the difference is already given as 6 meter by in the question, you can say. Now that divided by 6 meter divided by what is the L2, just now we have got that L2 is obtained as which one, just now we have got 2609.64, is it so? Just to check it, 2609.64, that is your 2609.64, you can say, right? It is multiplied by which one, 100, right? How much percentage you are getting that effective gradient value? 0.23 percentage. Now if you just remember that for this 1% effective gradient, the runway length should be increased by which one, this 20%. Now if it is for which one, 0.23 percentage of this effective gradient, and what is the percentage increment, you can say that is your 0.23 times 20 divided by this 1, that is equal to which one, this is 4.6 percentage increment. So therefore what is the final corrected length? Why we are saying it as final corrected length? Because beyond this there is no other correction recommended by this ICA and FAA together. The final corrected length, that L3, if you just observe, so what is that, you can say 1.046 times L2. So that is 1.046 times what is that L2, you can say. So just now we have seen 2609.64, 2609.64. So therefore what is that L3 final answer, you can say this is your 2729.68 meters is the final length, and this is the answer you have to select if you just observe, right? So hope this question is answered, right? Right. So these are all GATE 2024 toppers from Unacademy, and up to this 30th June this offer is there. Don't miss this offer, all of you. GATE 2025 preparation you can do at this 9,999 subscription amount only, that is 50% off on your GATE subscription you can get. So these are the latest, so this is plus subscription, 9 month subscription for 9,999, iconic subscription 9 months for this 15,999 only. What is the referral code you have to use? RP Civil is the code you have to use, and this offer is valid up to this 30th June only, right? These are the latest batches which are going to start on 30th June for this 2025 preparation. So hurry up guys. So up to 30th June only offer is available. Enroll for this plus courses, join, take this plus or iconic subscription and join for these courses, you can see. So for 2025 environmental science also these are the subjects starting. For 2026 civil engineering, these are the subjects starting on the same 30th June only. So those who are taking iconic subscription will get these books printed delivered to your home, right? So hope you are all understood. So like this we'll be having many other questions, many questions also will be solved, you can say, right? Thank you all of you, have a good day.